Hello and welcome to AI Frontiers, your podcast dedicated to exploring the most innovative research in artificial intelligence. Today, we're diving into a curated collection of papers from the arXiv preprint server, all submitted on May 16, 2025. These papers offer a glimpse into the current priorities and emerging trends within the AI research community. Our focus will be on computer science, artificial intelligence, providing insights into the cutting-edge developments in this rapidly evolving field. Computer science, artificial intelligence, represents a multifaceted field focused on creating machines capable of intelligent behavior. Its core aim is to replicate and often surpass human cognitive abilities in machines. This encompasses a wide range of subdisciplines, including machine learning, natural language processing, computer vision, robotics, and knowledge representation. The significance of AI lies in its potential to transform virtually every sector of human endeavor, offering solutions to complex problems, automating tasks, and creating new opportunities for innovation and growth. AI is becoming deeply entwined in our daily lives, from personalized recommendations and self-driving cars to medical diagnosis and scientific discovery. The papers we'll discuss today reflect the dynamism and breadth of this transformative field. After carefully reviewing these papers, a key research theme emerges: enhancing the robustness and reliability of large language models, or LLMs. Researchers are actively exploring methods to mitigate biases, improve factual accuracy, and ensure the responsible deployment of these powerful models. For instance, one paper investigates techniques for detecting and correcting hallucinations in LLMs, aiming to improve their trustworthiness in real-world applications. A second prominent theme is the development of more efficient and explainable AI models. As AI systems become increasingly complex, understanding their decision-making processes becomes crucial. Researchers are working on techniques to make AI models more transparent and interpretable, enabling users to understand why a particular decision was made and identify potential biases or errors. One paper, for example, explores novel methods for visualizing the internal workings of deep neural networks, providing insights into how these models learn and reason. Deep neural networks are multi-layered networks designed to automatically learn complex patterns from data. Convolutional neural networks, or CNNs, are employed in image recognition tasks, while recurrent neural networks, or RNNs, are useful for sequential data processing. The ability of deep neural networks to extract intricate features directly from data makes them essential for both image recognition and natural language processing. A growing interest is evident in multimodal learning, where AI systems learn from multiple sources of information, such as images, text, and audio. This approach aims to create AI models that are more versatile and adaptable to real-world scenarios, where information is often presented in a variety of formats. One paper introduces a new multimodal fusion architecture that combines information from different modalities in a more effective way, leading to improved performance on a range of tasks. One notable result highlights the effectiveness of a novel training technique for reducing hallucinations in large language models. The proposed method, detailed in one paper by Gupta et al., involves fine-tuning LLMs on a carefully curated dataset of factual statements and counterexamples, leading to a significant reduction in the generation of false or misleading information. This is a crucial step toward building more trustworthy LLMs for real-world applications. Deep learning, particularly convolutional neural networks and recurrent neural networks, is used for image recognition and natural language processing. Reinforcement learning is applied for decision-making and control tasks. Explainable AI methods provide insights into the decisions made by AI models. Transfer learning allows AI models to leverage knowledge gained from one task to improve performance on another related task. Let's examine the paper titled Mitigating Hallucinations in Large Language Models Through Factual Fine-Tuning by Gupta et al. The primary objective of this research is to address the issue of hallucinations, which is the tendency of large language models to generate false or misleading information. The authors recognize that this is a major obstacle to the widespread adoption of LLMs in real-world applications, where accuracy and trustworthiness are paramount. Gupta et al. Propose a novel fine-tuning technique that involves training LLMs on a carefully curated dataset of factual statements and counterexamples. The factual statements are designed to reinforce the model's knowledge of the world, while the counterexamples are designed to challenge the model and encourage it to avoid generating false information. The methodology of Gupta et al. Involves several key steps. First, the authors create a dataset of factual statements covering a wide range of topics. This dataset is carefully curated to ensure that the information is accurate and up-to-date. Second, the authors generate counterexamples for each factual statement. These counterexamples are designed to be plausible but ultimately false, challenging the model to distinguish between true and false information. Third, the authors fine-tune a pre-trained LLM on the combined dataset of factual statements and counterexamples. The fine-tuning process involves adjusting the model's parameters to minimize the difference between its predictions and the true labels in the dataset. The key finding of this research is that the proposed fine-tuning technique significantly reduces hallucinations in LLMs. The significance of this work lies in its practical approach to mitigating a major challenge in the development of large language models. Chen et al.'s study centers around the development and validation of an AI-driven system capable of predicting disease outbreaks with high accuracy. The authors address the critical need for early detection of potential epidemics to enable timely intervention and resource allocation. Their research aims to leverage the power of AI to analyze diverse data streams and identify patterns indicative of impending outbreaks, thereby enhancing public health preparedness and response. The methodology employed by Chen et al. Involves a multifaceted approach, incorporating data collection, feature engineering, model development, and validation. This involves gathering data from various sources, including social media platforms, news articles, search engine queries, environmental sensors, and public health surveillance systems, which is then pre-processed and cleaned to remove noise and inconsistencies. Attention mechanisms focus on the most important parts of the data. They are used in natural language processing, computer vision, and other tasks. These mechanisms help models understand context and relationships within the data. They improve the model interpretability and are key components for explainable AI. Suzuki et al.'s paper develops an explainable AI, or XAI, method for deep learning models. It combines attention-based visualization and gradient analysis. This method provides an interpretable explanation of model behavior. It identifies key factors that influence decisions. This helps build trust in AI systems. Looking to the future, mitigating biases in AI models is essential. Developing efficient and explainable AI is a key direction. Focus is needed on multimodal learning and ensuring data consistency. Ethical and societal implications of AI are important considerations. This requires a multidisciplinary approach. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.